All right, everybody, we're going to take a look today at something called law of cosines. So we had our law of sines to help us solve non-right triangles. Today we're going to look at law of cosines, which is another law that we use to find solutions to triangles that are not right triangles, but where law of sines just wouldn't work. So we'll talk about the two scenarios that we're going to be able to deal with. So one of them is side angle side. So if you're given side angle side, what you know are two sides and the angle in between. So side angle side. If that's the information that you have, you would never be able to use law of sines because you need a side and an angle opposite. You're missing, you don't have this side that's opposite, so we wouldn't be able to use law of sines. So that's one situation. The other situation is, what if you know three sides? You don't have any angles at all. Well, you'd never be able to use law of sines there either because you need a side and an angle opposite again. You don't know any angles at all. So these are the two scenarios that we're going to be looking at today. Now, the great thing about both of these is that there's only going to be one triangle or one solution for each one of these. Because let's look at the first one, side angle side. There's only one way to make this top picture a triangle. It's connect up those two vertices. One triangle, only one set of solutions. For the second one, for side, 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 if you have three numbers that actually work to form a triangle, if you remember back in geometry, you talked about something called the triangle inequality. If you add two sides, it always has to be greater than the third to be able to make a triangle. Then you're only going to have one solution. There's only one way to draw this. You can't draw it in different ways. So when we think about the options we have here, there's only one possible set of solutions that we can ever deal with. Now, when we look at that bottom one, I'm just going to tell you kind of up front, all of the ones that you're going to be given, the sides, they've already checked the triangle inequality for you, so you don't have to deal with that. So we're going to give you sides that work. But recognize that there could be situations. You can't just pick any three numbers you want for sides and make a triangle out of it. But for the ones that they're going to give you, they are set up that way. All right, so I want to go through and actually derive this formula so we can talk a little bit about what these would look like. So we're going to go through the derivation for law of cosines. Okie doke. So let's do this this derivation so you can see where the law of cosines actually comes from. It's not just magical. There's actually a way that we can do this. So I have a regular, just non-right triangle, ABC. So we have our sides and our angles. What we're going to try to do is come up with a formula that only uses lengths of sides and angles. But what I did is I dropped the perpendicular in and I made this little triangle right here with that perpendicular, the height, the right angle there at H. And then the other triangle I want to draw your attention to is this red one, so the one that's BCD. So we're going to use these two triangles to help us come up with the law of cosines. Now, just so you understand the labels, I made this bottom part, since I dropped the perpendicular to D, I call the base of this one X, because I don't really know what just that piece is. The entire bottom from A to C is B, so that means the other part would be B minus X. So just make sure you kind of follow on what I was doing for the labels there. Okay, what I want you to do is go ahead and write Pythagorean theorem for triangle ABD. So the Pythagorean theorem for that would say C squared equals x squared plus h squared. I'm just going to write some relationships I need to derive this law of cosines. Then I'm going to pick vertex A. I chose this because I'm going to do it for this angle. You could do this though from any vertex. So I could do it from B and have an altitude from A. I could do it from C. I'm picking A just so we have one to talk about. So what I'd like you to do is write the cosine relationship for angle A. So the cosine of angle A would be equal to, in this little green triangle, adjacent over hypotenuse. So that would be x over c. All right, and for what we're going to be doing, I'm going to go ahead and have you solve that for x. So if I was going to solve that for x, I'd multiply both sides by c. So c times the cosine of a. So that's everything I need in the little green triangle. Now let's look at the red triangle. I'd like you to do Pythagorean theorem for the red triangle as well. So we'd have a squared equals h squared plus b minus x squared. All right, now I actually need you to do the arithmetic, do the simplifying for that b minus x squared. So let's do that. So a squared equals h squared plus, we're actually going to multiply b minus x times b minus x. So first outside, inside last. So that would be b squared minus insides and outsides are the same. And you could say bx or xb, it doesn't matter, but I'll just go alphabetical. And then last would be plus x squared. All right. So I want to draw your attention to this relationship. Oops. So that guy right there. Now, there's a lot of A's, B's, and things like that, but there's also H's and X's. So what my goal is here is I want to try to write an expression or an equation, a relationship that only uses A's, B's, and C's. So what I'm going to do is I'm going to try to substitute now into that red box anything that has an H or an X, what that could be equal to in terms of A's, B's, and C's. So first thing I'm going to do inside the box is I'm going to do a little bit of rearranging to help you see something. So I'm going to take that X squared that was at the end and I'm going to bring it closer to the front. So take a look and see what I did. So I moved the X squared. And in addition, it's totally fine. You can add in whatever order you want. Now I'm going to draw your attention to this guy right here. So look at that, H squared plus X squared. Is there anything else that I could use that means the same thing or a substitute for? If you go back to our green triangle, H squared plus X squared is the same as C squared. So I can make that substitution. So I'm going to go ahead and do that. So I have A squared equals, that would be C squared. B squared is fine, that's the length of a side, minus 2 times B times, okay, now here's my next problem, this X. Now I don't want an X there either, I want only A's, B's, and C's. So let's look up top again to what we did in the green triangle. Look what X is equal to. I can make that substitution as well. So I'm going to put in a C times the cosine of A in for that X. So I'm pretty much all set here. I'm just going to do one last switch. I'm going to switch the order of these just so it goes alphabetical. So B squared plus C squared minus 2 times B times C times the cosine of A. And that is one version of the law of cosine. So notice, if you know 3 sides, A, B, C, you know all that information, you would be able to solve for angle A. Or what if you know 2 sides and the angle that's in between the A, then you'd be able to solve for little a. So this gives us what we need to have 3 pieces of information about a triangle to be able to find the 4th. And if you look on your next slide here, the one that I starred there, that's the one that I just proved, that I just derived. Now there's 2 other versions. Why? Well, you could have used either other vertex as well. And remember, the labels don't matter. You could use D, E, F, L, M, N, whatever you wanted, and you would end up with the same relationship. So the labels are on there just to help us be able to understand. So they have 3 different versions, so you can look from each vertex. But again, if you have different letters in your triangle, just trade out the letters, you do the same thing. All right, so let's try a couple examples. We'll do 2 of these kind of all the way through, and then we'll just talk about a couple others and get into some applications. So let's take a look at what you know about this triangle. So we know 2 sides and an angle, which sounds an awful lot like our conversations from law of sines, but look at where that angle is. It's not across from one of the sides. So I have 2 angles, or 2 sides, and I have 1 angle, but it's not opposite, it's included. What that means is you have side, angle, side. This is not law of sines, and I can't use it. I won't be able to set up that proportion. It is law of cosines. And one quick and easy way to do this is just look for the different labels. I see an ABC. There's no way I'm going to be able to use law of sines. It's going to have to be a cosine situation. So what's the only thing you can solve for then? Well, if you have angle C, the only thing in law of cosines you're going to be able to do is solve for little c. All right, so let's go ahead and put in everything and see if this makes sense that we can actually solve for this. So I can put in my value for A and B and cosine of angle C, which is 32.2. So what I'd like you to do on your calculator is go ahead and type in the 8 squared plus 5 squared minus 2 times 8 times 5 times cosine of 32 and see what you come up with. So go ahead, pause the video, type that in, see what you get. All right, so coming back, hopefully you type that in. I'm just for rounding purposes for writing, going to write what it is rounded. But remember to leave all of the digits on your calculator and then take the square root. So make sure you leave all of those on there. All right, so if you see on my calculator, I have the 21.3, the whole thing. So when you want to write it down, fine, round it, that's great. But when you're actually going to do the calculation for accuracy, we want as many places as possible. So I'm going to actually do the square root now. So second and then use your answer function, or you can highlight whichever you want, and then we can round when we get to our final answer. So just be careful on the rounding. So it looks like we have 4.6. So that's our little c, which is fabulous. I have a side of the triangle now. I have my little c. Now think about what you know. There's an angle and a side that are opposite each other now, right? We know side c and angle c. So you don't have to use law of cosines again. We only ever need it once because now we can go back and use our ratios, our proportion, to be able to find another angle. So we know everything about C. Now we have to decide which one are we going to find next. For rounding purposes, what we're going to do, because now we're using a rounded number, right? 4.6 is rounded, so we're going to be off a little bit as we go. The more digits you use, the more accurate it's going to be, but we're going to be off a little bit. So people can check their answers a little bit better, we're going to always find the smallest angle first. So we're going to go smallest to biggest for finding those angle measurements. So the next biggest angle, or the smaller of the two, if you want to think of it that way, between A and B, which of those angles would be the smaller one? Well, it'd be B, because side B is shorter. So I'm going to go ahead and find angle B next. So we'll go smallest to biggest. That way, when you guys are comparing your answers, we'll be right on track with those decimals, and you won't have to worry about checking things that are off a little bit. So cross multiply, divide, take the inverse. So it'll be inverse sine of 5 times the sine of 32.2 divided by 4.6. All right, so our angle B, go ahead, pause the video, do your calculation, and we should get 34.4 or 35.4. Don't make sure that you don't just assume that it works for you. Try it on your calculator, make sure that you're fine and you're in degree mode. All right, so we have two angles now, right? We know angle C and angle B, so only one angle to go. The only one we don't have is angle A. Well, cool, we can find angle A now. How would you find angle A if you know the other two? Just subtract from 180. So kind of that same step we were doing in law of sines. So subtract off the two that you know. So we don't need to use either law of sines or cosines now because we're just doing that find the third angle. So that last one would be 112.4. So law of cosines kind of gets us in the door. We can find that one new piece of information, and then we can use what we know from law of sines to find the rest. Okay, so that's a side angle side. Let's do a side, side, side now. So take a look at what you're given here. We know three sides of the triangle, so side, side, side. So we definitely can't use law of sines. It has to be law of cosines. So let's start with finding one of the angles. So in order to kind of decide here, I'm going to do the same thing I did in the last one. We're going to go smallest to biggest. So I'm going to find the smallest angle first, and again, just to help with rounding. So which is the smallest angle in that triangle? Well, which is the shortest side? Looks like C. That means I'm going to find my angle C first. And that's, again, just to help us with our rounding and make sure that we're not having issues with our solutions as we move forward. Now this one, I can put in all the side lengths. All right. What are you actually solving for then? If you know the three sides, what you are actually solving for in this case then is angle C. So let's talk about what work we can do here. So we can do a little bit of arithmetic. So I can do some squaring. So I can get that done. And I can do some multiplying here. 72 times 2 would be 144. And it looks like I can do this. I can put those numbers together. That's just adding two values. So I can do that. And then a lot of people get to here, and here's where the epic disaster usually occurs. What everybody wants to do right now is to do that subtraction, the 145 minus 144. Because it's easy. It'd be 1. Wouldn't that be great? Well, this is your variable, right? You're solving for cosine of C. I'm going to write something here. You don't have to write it, but just look. If you had an equation back in pre-algebra or algebra that was this, basically parallel equation here, right? It's exactly the same as the red one, just instead of writing cosine of C, I wrote x instead. How would you solve that for x? What would be the first thing you'd have to do? Well, you'd have to subtract the 145. And then you would divide by the negative 144. You can't put the 145 and the 144 together. They're not like terms, so just be careful. That's kind of the problem that people run into. So we want to be super aware of what we're doing here. All right, so we subtract the 145 on both sides. Looks like that's negative 96. Then we're going to divide by the negative 144. And over here as well. And I'm going to bring my variable over to the left. So my cosine of C would be negative 96 divided by negative 144, whatever that is. Now, I'm not going to spend a whole lot of time simplifying that fraction because what I really need to do now is get rid of cosine, which means I need to do inverse cosine on each side. So I need to take the inverse cosine. So who cares what the fraction is over there? Just type it in. Now they're both negative. So a negative divided by a negative, that I probably would deal with. So that's a positive. But I'm just going to go ahead and type it in like this. So I'm going to do, clear that out here, inverse cosine of 96 divided by 144. Oops, forgot my 1. That would be wrong. Okay, so insert a 1 there. And I'm coming up with 48.2. So my angle measurement for angle C would be 48.2 degrees. So don't worry about too much simplifying there, but just make sure you know how to solve that equation for the C. So make sure you're doing opposite operations. Okay, so here we're back to that same place again. I know everything about C. So when I think about what I have left to find, I need all my angles. I just found angle C, so I know everything about C. What I don't have is angle A and angle B. So I'm going to find the next smallest angle. So between A and B, which would be smaller, would be angle A because side A is shorter. So I'm going to go ahead and find angle A next. So 8 is to the sine of angle A, as 7 is to the sine of 48.2 degrees. That's the C that I just found. So again, it's rounded. It's going to be off a little bit, but the more digits we use, the more precise that could be. Cross multiply, divide. Take the inverse. So 8 times the sine of 48.2 divided by, whoops, went too close to the edge there, divided by 7. So do inverse sine, get our angle A, which looks like it's 58.4 degrees. That gives us 2 angles. So now again, just like last time, if you know 2 angles, super easy to find the third, just subtract from 180. So again, you only ever need to use law of cosines once. That gives you that one piece of information that tells us everything about one side and one angle. And then you can go ahead and use law of sines and subtract from 180. So I'm coming up with 73.4 degrees. Alrighty, so what I'm going to do for the next couple, we're not going to solve all the way through. I just want to talk a little bit because then we're going to do an application and then another way to find area of a triangle that's not right. So we're just going to talk these through. I'm going to have you pause the video so you can jot down the answers, but we're not going to solve them all the way through. So take a look at what you know here. So we have given 2 sides and an angle. The angle is not opposite. It's included. And again, how do you know that? What do you look for? 3 different letters. So this is a side angle side. The only thing you'd be able to solve for first would be little c. So you'd be using this formula. And you'd be solving for little c. So this is just like example 1. If you want to go ahead, pause the video, or you can jot down your answers here. And if you want to use this as a review question and double check and make sure you know what you're doing, I'm going to give you the answers here so you can check your work. I think most of you should be fine, but we can solve for side C. Once we have side C, we use law of sines. We'd find angle A next because it's shorter, and then angle B. All right, take a look at the next one. Tell me what you know about this. If I could hear you all answering me right now, you'd be saying 3 sides, 3 sides. Okay, so if we know side, 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 can't use law of sines either. So we're going to have to find an angle measurement. We're going to find the smallest angle first. So that would be C. So you'd be doing C squared equals A squared plus B squared minus 2AB cosine of C. So what I'd like you to do on this one, we're not going to solve it all the way through, but I just want you to at least find that first angle C. So go ahead and pause the video, see if you can plug the numbers in and actually solve for C. Okay, back to take a look at how we did on finding this angle C. So I used my law of cosines. I did the arithmetic I could. Solve for cosine of C, opposite operations. Remember, you subtract first, then divide. Take the inverse on both sides, and then we solve. Now, when you do the inverse, I ended up with 17.7, so I found an angle. Now remember, to find the next 2 things, the next angle and the last angle, you don't have to go back to law of cosines. We know everything about C now, so we can find another angle. What would be the next smallest angle? Look at the next shortest side would be B. So you could use law of sines to find angle B and then subtract from 180 to find angle A. I'm going to go ahead and pause the video, see if you can find those 2, and then I'll give you the answer so you can double check your work. Alrighty, and there's your last two then. So angle B using law of sines, and then angle A solving from 180 to find those last two. Okay, so let's talk about a more real life scenario that this would come into play. So I want you to take a look at this situation where it's a pilot and they're flying to avoid a thunderstorm. So they were supposed to go straight from Houston to Oklahoma City, which was 396 miles, but they had to avoid a thunderstorm. So they changed course. They changed their direction 28 degrees off their direct route, and they flew for 175 miles. Then they were able to turn back and head straight to Oklahoma City from that point. So what the question is how much further did they have to fly by changing their course? And think about why this might be important to the pilot to know that. So why might he want to know how much further he's flying? Well, one is to take a little bit of time about how long that's going to. All right, so let's think about what you would have to calculate then to be able to do that, to figure out how many further miles. And, oh, I was talking about too, just had to stop the video for a second. Sorry, somebody had a question. We were talking about why would you want to know that? Besides how far they're going, how about how much fuel you have, right? Because if you're going to fly a lot further, we want to make sure we have enough fuel. It's one thing to run out of gas in a car. It's a little bit more high stakes if you run out of gas when you're flying. So we need to figure that out. So take a moment, see if you can pause the video, see if you can figure out what do you have to find and how are you going to find it to be able to see how many further. All right, so what you really need is this. So we need from the turning point to Oklahoma City. Once I have that, I can figure out the total miles that they flew, so the 175 and this. And then to figure out how many more miles that is, I would take that total of those two sides and subtract that 396, so see how many more they'd have to fly. So now in a real life setting, they don't have labels. So it might be kind of nice if we put labels on this so we had something to talk about. So I'm going to go ahead and call Houston C, doesn't matter. And then I'm going to call my turning point, I guess, A, and my Oklahoma City B. It really doesn't matter, but it makes it easier for you to substitute into the formula if you think of it that way. So the side that we're looking for is little c. Our 396, that would be little a, and our 175 would be little b. So to be able to find our side C, we're going to set up our law of cosines. So I'm going to go ahead and have you pause the video and see if you can calculate what that little c would be with those numbers. All right, so by my calculations, looks like 255 miles would be how far that from the turning point to Oklahoma City would be. All right, so how are we going to calculate then the total miles that they flew? Well, they started at Houston and they flew to that turning point. That was 175. And then from the turning point to Oklahoma City, they went another 255. So it looks like they'd be at 430 miles traveled altogether, having to avoid that storm. So how many more miles then did they have to fly? So what was the difference, or how many more miles did they have to fly because they avoided that storm? Well, they went 430. They would have only had to do 396. So it looks like they're made their trip 34 miles longer, which actually isn't that bad. They didn't have to avoid for too long, but you can imagine having to divert further would cause a little bit more trouble. So then you have to start thinking about, okay, do we have enough fuel? Do we need to land somewhere else? Kind of important calculations, but it's all using trigonometry. Okay, the last part that they talk about in this section in 5.8 is a great way to solve and find area of a triangle when you know three sides. So we talked about side angle side already in 5.6, a way to find it if you don't have, say, the normal traditional area formula for a triangle. Normally for a triangle, everybody gets kind of drilled into your head. It's always 1/2 base times height. Well, that works fabulous if you have the base and the height, but what if you know the three sides instead? So we have something called Heron's formula. In some textbooks, they call it Hero's formula. Excuse me, I think it goes back to the Greek mathematician's name and kind of how that's changed over the years, but Heron's is how our book refers to it as well. And it uses something called the semi-perimeter, which is a wonderful, wonderful thing. So we just talk about this idea of a semi-perimeter. Now, when you use the word or the prefix semi in mathematics, think about what that means. Like, what is a semicircle? Well, a semicircle means half of the circle. So a semi-perimeter is half of the perimeter. Now, do you remember what perimeter means? The distance around a figure. So if what you know about a triangle is side, 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 we're going to be able to find that perimeter. So the S in this is taking the perimeter, add the three sides, and dividing by 2 or timesing by 1/2, however you want to think about it, and then using that in this formula. I know it looks a little goofy, but it's a big radical, and it's a product of four things. S, which is just a semi-perimeter, and then S minus each of the side lengths in whatever order you want to do that. So you don't need to drop a perpendicular, you don't have to find the altitude, you don't have to find an angle. We can just use the sides. It's fantastic. Okay, let me give you a real life situation about this. So say you have a flower bed in your yard. It's 2 yards by 6 by 7. It's a triangular shape. If you needed to go to the store to buy, say, mulch or wood chips or whatever to put in that area, you'd want to be able to figure out how much you need to buy. So without having to go back 7 times because you either got too much or not enough, whatever, we can actually figure it out without having to figure out a height of it or figure out an angle, because it's really easy to measure the outside dimensions of something like that in your yard. So the first thing we do is figure out the semi-perimeter. So we're going to add up the 3 sides and divide by 2. Now, oftentimes these are not going to be nice numbers. They're not all going to be whole numbers, which is fine. You have a calculator. We get 7.5. Okay, so how do we calculate the area then? So we're going to do a product, big square root, and we're going to multiply S, 7.5, times S minus each of the sides. Now, it doesn't matter which one you call A, B, and C, so I'm just going to pick one. So minus 2 minus 6, and then the 7.5 minus 7. Now you can actually type it exactly like that into your calculator. What I find is a little bit easier to do though is I go ahead and I just subtract in my head, or you can subtract them separately and do the subtraction so the numbers that you're typing in there are a little bit easier to deal with just for length of time. So we multiply those together and then take the square root. So we end up getting, and double check that you do, 5.6 square yards. Now, how can that help us? Well, if you know that each bag, say, at the store has 2 square yards of mulch in it, how many bags would you have to buy? Well, if it's 2 each, we need to get up to a little bit more than 5.6, so we'd probably want about 6 square yards. We'd want to buy 3 bags. Now, maybe not that big of a deal if you have to go back and forth to, say, Walmart or whatever to buy or to not return. But if you're bidding a job and you're doing landscaping, it's very important that you do accurate calculations so you're bidding the job appropriately. So it makes a lot bigger deal, I guess, if this is something financially you have to deal with. So really great and easy way to find the area of a triangle when you know 3 sides. Okay, so we talked about how do you solve non-right triangles using law of cosine, so side, 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 and side, angle, side, and then also how to find the area of a triangle with 3 sides. So we're going to just do a couple quick practice problems with that, and we can handle now solving any non-right triangle we want.